This is Lab 2, bar magnets. Introduction. The purpose of this lab is to determine how magnetic strengths vary at different distances and orientations. From this, we're able to determine the relationship between the field's magnitude and distance. Key terms and concepts, we have magnetic dipoles, the Biot-Savart law, as well as magnetic field on axis. For introduction, a brief overview of results. Y for our graph is going to be y is equal to negative 3.0169x minus 15.571, and it shows an inverse relationship between the magnetic field and distance. Our system is going to be our bar of magnets, and our surrounding is everything else. So the experiment was to download the magnetometer app, align the phone with 0BX, which is Earth's magnetic field, find BX max, BY minimum, then rotate the phone to find BY max and BY minimum. Find the distances where BX is equal to 20, 70, 120, and 220. You have to do those 3 times each. Put these values into the spreadsheet and find ln BX versus ln R. Using where bx is equal to 0, determine the perpendicular component where b net is equal to 100. Then measure for bx, by, bz, and repeat this 3 times and compare this to the dipole field equation. And here is a picture of the experiment. Here are the results with as well as our testing points. Possible room for error. The metal might have been too close to phone. There was also computer jewelry and other phones, except there could have been a wrong position for the phone sensor, wrong measurements, as well as magnetometer errors. Calculations. To calculate for mu, we start off with the given equation from the graph, and using the equation for the magnetic field of a bar, we set that equal to the magnetic field of a dipole on the parallel axis, and then from there we solve for mu, in which we find to be 0.864. And then we also plug in r to equal to 1 because we're trying to find that y-intercept, so ln of r is equal to 0, and then of course e to the 0 is 1, and that's why we set r equal to 1. Here's my code. Here are my code results. It makes a lot of sense because, of course, on axis with the dipole is going to be pointing from south to north, and then of course on the perpendicular axis it's going to be pointing in the opposite direction. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The Earth's field would cause some discrepancies, which would either add or take away from the magnetic field, and the graph would be skewed and would no longer show an inverse relationship between distance and magnetic forces. What if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? If we were to stack the magnets, their magnetic dipole moments would add together and the field would be about twice the size of the original distance r. Conclusion. In conclusion, this lab effectively demonstrates the inverse relationship that strength of a magnet has with the distance from the magnet. In our lab, we were able to provide this relationship with our graph, where we found the y component to be equal to negative 3.0169x minus 15.571. As distance away from the magnet increase, the magnetic field decreases.